Hello, you're back.
You can hear me now?
Now we can hear you, we can see your screen.
Okay. So at what point did you guys stop hearing me?
The moment when you started, it was in I think the second slide when you were discussing about the T in the box. So the box with the T type.
Oh, here.
Yeah, you are there.
Okay, let me brush over it really quick so that we can go ahead. Yeah, so at any point the screen goes missing, guys, let me know because I don't know where the problem is. Okay, so like I was mentioning earlier, mm, now let's learn more about generic classes and methods. So I said I wanted us to think of this from a real world scenario. Something generic. Have you ever bought an electronic device and you can't identify with the brand? Like it's just an electronic, there's no branding on it or anything. So this basically a scenario compared to where you have an electronic device, let's say a headset, but it's associated to a brand like Samsung, LG, or even Apple, right? So the fact that you have one that has no brand in it, that is something generic. That is why in generic classes in C Sharp, when we, for example, say we are actually defining a class here, for example, public class box. So the name of the class is box, but remember, we usually need to actually tell the type of that class, like the type of data that should be returned. In this case, we ought to have said something like an int or a string, but instead we only have T. So T here stands for like something generic, which means it's one class, but this class can be in different forms. It can take an int, can take a string, or any other data type that you can think of. Coming down to methods, methods is the same scenario. We have like a public static void swap is the name of the method, but then instead of having to define explicitly the type of the string during definition, we only designate it with a T. This T simply means it's generic. It can take any type of data, either string, an int, a double, yeah, anything there. So in short, it's a method, but this method can exist in different forms, in different data types like string or int. And then how do you use them? Now, when you now use them, here's where now you actually tell it. Today, we want to have this method as an int. Tomorrow, we want it to maybe a string. For example, let's look at how this class is used here, the class box. Its definition is generic, but its usage, we have to tell it which type of data type. So in this case, we have var int box equals to new box, which is a new instance of that class. And then now we tell it the data type. We could have something like, let's just say, let me just give you a real quick what it will look like. It could be something like a var, then a string box, then new box, But then now, in this point, it's now a string and not just a generic one like we had earlier. Okay, that is it. As for the classes, coming down to how you can now call it as a method. Now we have it here. Like the method name is swap, but remember during definition we said it's generic. But now when we call that method or we invoke that method, we have to tell it what to expect as a return type. In this case, it's string. So, which means if it was supposed to be an int, it will have something like swap, and then int, then have your arguments inside there. Let's say ref int 1, and also we have ref of int 2. So that is what happens, all right? So until this point, we are still okay. You can hear me clearly and you can see my screen.
Yes, you're together.
Okay, thank you. So let's move on to slide number 4. So remember last time I mentioned before you guys lost me, Brian Kemboi handled collections. So we also have generic collections where you have a list, and this list, a list can have it can be a generic list where it can take in any type of data. So in this case, just denote that by using a T to tell that we can call this list as either a string or an int or any other data type. Dictionary. Dictionary is like a key value pair, a collection of data. So in this case, if we have a T key and a T value, what we're saying is that it could be a string as the key or an int as the value, or the vice versa, an int as the key and a string as the value. Same to queues, same to stack. So in a nutshell, what we're trying to say at this point is that something generic is like, think of it like we have a box, and this box, we don't have to actually store in one type of data inside there. Inside that box, we can have a string, we can have an int, we can have doubles or anything, or even queues. The thing is, it's like a general box, but during storage, we now define it. Okay, in this box today, we've stored int. In the next day, we say, okay, today we stored strings in this box. Yeah. So moving on, I think we can now look at interfaces. Okay. So under interfaces, a straightforward definition of interface is like interfaces define a contract that classes must implement. And I remember I was giving an example, using a real world example, a case where we have a vehicle. Let's think of a vehicle as a class vehicle. Vehicles, and then we have different types of vehicles which will inherit properties of other vehicles. A good example, we have types of vehicles. I'll give, for example, let's say we have a Lamborghini, a type of a vehicle. We have a Toyota, a type of a vehicle. We have, which kind of example can I use again? We have a Ford, a type of a vehicle. Any vehicle always has a sound while it's moving or while the engine is started, right? Which means like all vehicles will have a method called, let's say, start engine. But how these vehicles implement the start engine is what is different. For example, we can have a Lamborghini, you know, the sound that a Lamborghini makes, that ta 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 ta. And then we have a Toyota, that's the normal kiendanga. Then we have also the sound that a Ranger will emit when it started. So it's like we have a one class with a method that is common to all. This method, let's say, is like start engine. But then how these types of vehicles implement this start engine is what differs. Now that is where interface comes into play. So an interface, you can think of it like a list of rules. These rules, we mean like methods or actions that different things, which are classes, must follow. The cool part is that the actual classes decide how to follow these rules. And we look into that with the code. And then under interfaces, we can also talk about abstraction, like an interface separates what a class does from how it does it. Yeah. Then you also have multiple implementations where different classes can implement the same interface in various ways. And then talk of polymorphism, where interfaces enable polymorphic behavior in OOP programming. So confirm to me if you can still see the screen. Are we still together?
Yes, we're together.
Thank you. So let's move to the next slide really quick. Yeah, so let's see how we can actually implement an interface. So you need to define an interface, for example, public interface, iAnimal. Then its common action is like make sound. And then we have to now implement it in a class where we say public class dog. I will say like it will inherit the interface or it will interface with the animal, iAnimal, where we now have the method make sound, which will return a sound hoof. Then we can have the same another class interfacing with the interface. That is, for example, a public class of cat, which will interface with the iAnimal. But now remember, it had an action of make sound, but the implementation is different. For example, in the dog here we have oof, but in the cat we have meow. Then let's look at a simple use of polymorphically. For example, animal equal to new dog. Then you can say console.writeLine animal will make a sound. We'll look into that in terms of code to get a better explanation of what it means. And then we have generics versus interfaces. So let's look at contrasts or differences or similarities between generics and interfaces. So let's see the purpose of generics. Generics are to ensure like we have a type of code and a code that can be reused. Interfaces, they just define a common behavior. In terms of compile time, generics, they do type checking, interfaces, contact enforcement, where we have an action that has to be implemented using different ways. Runtime, Generics, they ensure type-specific code. Interfaces will ensure polymorphic behavior. And then use case, generics can be used in collections and algorithms. Interfaces can be used in abstraction and design patterns. So real-world examples, we can have generics in .NET, where we have list, a generic for type-safe collections, a task tip for asynchronous operations returning a value. Then interfaces in design patterns, you can have a repository for data access, abstraction, or a disposable for resource management. Combined usage, there it is. And then finally, in the last slide, let's look at a conclusion of what power of generics and interfaces can have. First, as a recap, they ensure code usability, where you can write once and then use with the multiple types. Type safety, catch all errors or most of the errors at compile time to avoid errors that will arise during runtime. Then abstraction, let's say you separate the interface from implementation. Flexibility, adapt to changing requirements easily. So that is like a brief overview or introduction into the power of generics and what we call interfaces. So let's now look at a few examples of how this can be implemented in C#. So I'll just shut down my PowerPoint so that we can just have only my VS Code showing. So I don't want to save anything there. So I'll open up my C#, my VS Code, and then we can start from here. Let me just delete everything so we can start fresh. Yeah, after that point, can someone actually confirm that you can see my VS Code clearly? Because I don't want to leave you guys in the dark.
Yeah, it's cool.
Thank you. You'll have to bear with me. I'm kind of running a very slow machine, so it will take some time to respond. So bear with me. So first, I want us to start with the generics. So I have an example. I'll just write that down in the code, and then I'll do an explanation. So let's have a class, a generic class, and then this class, we're going to use it to see how we can implement generics in C#, where we have a class that we should take a generic type, but we can call it many times using different types of data type. So let's say we have public class, a class of box, but we don't want to give it any type. We are going to give it a generic type, let's say using a T denotation. And then what we have next is to have something like a public T item. Let's do item. It get and set. I don't know why it keeps prompting me to keep sharing. Hang on, guys. Then we have public. Yeah. Void show item. Okay. Please don't hang around. Yeah. So then we can console right line. Then we can have a string literal, and then we can say item, and then the item itself, the item that we have on top there, and close with a semicolon. Then now this is like our box now, right? So what happens here? We have a public class named box, but this box, we are not giving it any data type like either an int or a string. What we're trying to do here, we're trying to make this box generic so that it can contain any data type. Call it a string, an int, a double, or a character. It can be contained in this box. And then now we're going to write another class where it shows us how you can actually put anything inside this box. So I'll just comment it somewhere here so that we say now you can put anything in the box. Let's go. Let's have the main program now. Public class program. Then our code block. Then public static void main. Then you should expect something like a string args, and then a number of arguments. Yeah. Then coming down, we can now, let's say, remember we had a class of box. Now, in this case, what we do, we call the box now, but now what we tell it the type of data that we want to store in this box. So in this case, let's say you want to store an int, right? So once you have that, int box, like the name of that class, then equals to new box int. We have to invoke it that way. Then we can now set, remember we have an item where we have the getters and setters. Now what we're going to do here, we can now use int box, which is the initialization of that box class, which is generic. So in this case, we can say int box, then dot item equals to 10. If I forget semicolon, let me know because I'm not used to semicolons. Yeah. Then we can do the same thing. We can call the method with that generic class. Let's say int box, then show item. Show item. So before even I run this code, can like anyone, do you have an idea of what will be the output of this code when I run it? Any idea? Any clue? Any clue from anyone in our meeting? We want to make the session interactive. Any clue? Okay, so if there's no clue, let's continue. I'll explain what will happen. Let me go back to where you are from the VS Code. Yeah, so what happens here is that this is what we call the generic box. So when we talk of generics, we first construct that generic class or method, which is what we refer to as a box to make it understandable. So because it's generic, it can contain anything in that box. In this case, our class is box. The box is generic, and then we're trying to set the value of item, and then we have a method here. This method is show item. So once we set this value, it will get it, and then we will have the value shown here. Now this is what we put inside. We now have the main program or the main class, which is the main class of the program. And in this class, we have a main method. And this main method, we are trying to instantiate the generic box that we had earlier. But the different thing here is that we now tell it exactly what we want to put inside the box. In this box, we want to put an int. That's why we have box of type int. So box of type int, and then the name of that box, let's call it int box, equals to the new box, and then the type int, then we invoke it. And then now we want to set the item. Remember, we have item here. So int box dot item equals to 10. And then we're also calling what we call the method of that generic class, int box dot show item. And the method itself has a string item and also gets the value of the item that we've set here to be 10. So which means if we try to run this code, we should be able to get item semicolon 10. Let's run. Let's run and see. So yeah, give this computer time. It takes time to think. It's kind of an old computer. So let's see. I've clicked on run. It will run. Yeah, as it builds, let me know if you're still together with me. You can see my screen and hear me clearly.
Yes, we can still hear you clearly.
Thank you. So we will have been moving to the next task. Yeah. So I don't know if you guys are getting what we mean by generics and how I've implemented it here. Yeah, almost. Yeah, sure. So you can see what do we have here? We have item 10, and that is what we expect because we have here what to be printed in that line, item, and then the value of item which we will set now in the implementation of the generic box to be 10. So that is how we've actually used the generic box to store an int inside or to implement a method that should return an int. Now I want us to take it a step further and also store a string inside. So how do we do that? We can actually follow what we've done here. It will be quite simple. So if you look at how it goes, you first bring the type. This is of type box, right? But the data type is now a string. All right. So in this case, we had int box. In this case, now I want to, because we are working with the strings now, I can call it string box. So this will contain a string equals to, then instantiate that class by calling it new box, still a string data type, and semicolon. Then what we can do, we can say string box dot item. Then we can assign it to an item like say hello or generics. Generics should work fine. And then we still want to call this generic method that is a string box. And then we call the method which is show item. And that's it. So what do we expect? What we expect here is that when I now run this code, we should get something like item generics. Item, which is this, and then the value that we have assigned to item is now generics. So that is what we expect to be printed in our console. So I'll clear up everything once more, and then run this my program once again. The point is that we are making our code reusable. We have one box or one implementation, but which can be used using different data types, int, string, or just anything. Yeah. So as you can see, what do we have here? We have item 10, and then we have what we call item generics. So that is like a simple implementation of how you can work with generics. Next is we want to see how we can work with interfaces. So just a minute. So I think I can comment out what we have here as we move on to interfaces. Yeah. So just a minute. What do we have here? So let's move to interfaces. Let's call this 2.0 and then interfaces. Yeah, so what we said, a quick reminder of what we discussed earlier about interfaces. Interfaces, what you need to do, like think of it as a list of rules. For example, I gave you an example of how we have a class of vehicles, and each vehicle has its own way of starting the engine. Yeah, and again, I used examples like how do you call it? An example of we have a Toyota, we have a Lambo, and then we have something like a Ranger. All these vehicles, when they move around, you will always hear different types of sounds. One is way too noisy, it goes silent, then all of a sudden it's noisy. One just has that uniform sound as it moves. Also look at it in terms of animals, a cat meows, a dog woofs, something like that. So think of it like a list of rules that has to be followed, but then each class has its own way of implementing it. Okay, now let's use an example here. So I will have something like public, oh sorry for the caps, public interface. Then let's call it iToy. For that interface, actually it should be iToy because it's an interface. That is the correct conventional of defining that. Then let's say void make sound. Yeah. So this is the rule. The rule is that every toy must make a sound, right? Every toy must make a sound. And then how then does a specific toy makes that sound? And that is what we now want to work on, okay? Now, let me show you what happens. Now we're going to have public class. Let's say a public class of a toy car, right? And then this toy car interfaces iToy. Then the block where we have the implementation. Sorry, I don't like disorganized code. Okay, that's what I mean. So we have now the public class car, which will interface with the toy. So the car class really has to follow the rule. What is the rule? It must make a sound. And then what is the difference? Each car has its own way. Each toy has its own way with its own sound. So we have public void make sound, which is the rule. Then now tell us, how does that rule applies in the case of a car? We can have console dot write line. Then a car will do something like vroom vroom, and that we have it there. I've used compiler to complete that. Public. This will be public, not public. Yeah, public. So you see what happens? We have an interface of toy. The interface will give us the rule. With the rule is make sound. Now, each toy, is it a car? Is it a doll? Is it a bike? They have their own ways specifically for making sound. That is what we're going to do here. What we're doing here is like we're now defining a class of car. Class of car has to interface with the toy so that it must make a sound, but then it has its own way of making that sound. Okay, so what we can do from here, let's try run this code, and then we see what will be the output. What do we expect? We expect to see a vroom vroom painted on the console. To help clear, have it in its terminal, I'll comment out our generics. I'll comment out our generics, and then let's run what we have. Also clear the terminal. And then let's run what we have. Yeah. Let's see what we got. Frozen. Just a minute. Yes, we get back to work. Guys, can you still see my screen?
Yes, we do.
Okay, yeah, thank you. So just give a minute. I'm having a freeze kidogo. Kidogo tu tumekuwa na shida kidogo. Let's run again. I hope it doesn't freeze again. Does it want me to wait a minute? Why are we not having that? Clear. Let's run again and see if that will still work. Failed to build. Would you like to continue in the last successful build? I don't know why we're having this problem here. Brian, do you have a solution to this?
Okay, how about your first run .NET run, like
Okay.
open with your terminal, then just type .NET run. We will be able to identify the issues. .NET build. .NET build. .NET build.
Okay.
Are you inside the project? Like I think you're inside another project. You must get into MLSS series. Like you have to get into it because now you're on practice.
Okay, and then that's okay, right?
Yeah, and then let us see if you are inside the program. I think you're inside then .NET build. Yeah, from there.
From here.
To .NET build.
One
So
error.
let's read on that error. Like you could expand your terminal, we'll be able to identify. So say error program do not contain contain a static main method. So it's inside your program for the entry. Let's check your entry point of what you're trying to log on your C# code here. So this is the code. This is the only code you want to run.
Yeah, this is the code I want to run.
Yeah, you will need to, like for instance, so that console.writeLine to work, you should have that main method. Like for instance, when you are working with generics, you had to write the public static main or this one. Where is it? This one, class program. So this one is required to run the program. Yeah. So you could just yes, you can just copy it and then bring it just below the other code. You'll be able to have it.
So you should have it right here.
Yeah, you have to type now that program because these are two other different, like that's an interface to ITO and then we have car. So for the main method, it should be like even outside. Bring it like outside the car class, like outside it. Just after the car class definition, you can just bring the main method over there so that C# can start. Yeah.
Okay.
So
right here.
No, like outside the car. Like for instance, just undo your programs and then, or you can just please.
Yeah, so you are there. So it will be outside here. And at 33.
My screen is freezing. Let me see. Like we have your code public class car, which implements toys. Just maintain the other code that you had for car. And then just below now, after every implementation of the car and the parenthesis closes, just go below the car and then start the static main method, the entry point of your code. So you still have to remove the main. The main cannot be inside the class of car.
Omollo.
Hello?
You need to have, you see the way we usually work with Java, that the main class should always be the one that calls now the object you're creating, which is the car toy, which is the car which is interfacing your toy. So this public main should be on top of the public class.
I should have, let me pick up this. It should be
just copy
here.
Put
right?
You see
there.
That line you've added for public static void?
And then open the parentheses.
Put it up top. Put it up top before the public class car.
Okay, then I have everything inside there.
Should
whatever Copilot is saying,
then you have everything. Yeah.
So now you have to, all right. So in there now you have to call.
Your
Just
car.
a minute.
Your screen is frozen.
Masila is frozen now. Let's see. So we have public static void main, and then the block of the code. Why is
Okay.
it showing?
Omollo, can you just undo like for instance, what we meant is you can have this class. Let me just explain. Like, for example, public class car, it implements the
Okay.
ITOI, right? So just get
Yeah.
rid of this public static void main because you have it outside. So just remove this code inside it. No, this one inside, this one, the other one inside, not that one. This one.
This
Just
one.
below inside the car.
Oh, this one, right?
Let me wait for your cursor because I think your screen is freezing. Yeah, so just whatever Copilot is telling you over there at line 33, just accept that first of all.
Mm-hmm.
The moment. So we have the class over. Did you have this class dog, now
Okay.
class car?
No. Okay, I've got the point. And like these ones are my like interfaces, right? So
Yeah, this.
once I'm done with the interfaces, I should then now have my main program where I have the main method. Inside there,
Exactly.
I can now call the car, call any implementation that interface to what we had right on top.
Exactly.
Okay. So okay, fine. So let's
After
just
then
go
you
on.
can just implement there.
Okay, so let me just do that real quick. So what we can now do, let's have something like another class, a class that will run our program. So let's call it public class program. And then let's have the implementation of that program. Now here we need to have a public static void main now, right? Then let me
Yes.
accept what we have there. So what happens, sorry for that. So let's see. Clear. So I just do a quick recap so that we can all catch up. So what we said is that interfaces. Interfaces, they make the rules, and then that rule has to be implemented in specific ways by other classes that are interfacing that rule. In this case, our interface is interface of toy, and this toy must make a sound. The difference is that how they make sound is implemented differently. For example, a dog can do a hoof hoof. We can have like a cat doing a meow meow. So after doing that, let's say this is our main class for our program. Inside this program, we now define our main method, which is public static void main. And then the arguments, there we have them. And then now, what we're going to do, we now want to play with these toys. First of all, we have a toy dog, which has interfaced iToy. So how do we do that? Remember, it's dog, and then the name of that class dog will instantiate that class of new dog. And then remember now using a dog. A dog makes a sound, right? It's like what we're doing here, we're now calling the rule of the dog using its implementation, okay? Which means if we now run this program, what do we expect? We expect something like a hoof, hoof printed on the console. Yeah, that is how we implement it. So from here, we already have one toy, which is a dog. We are going to add another toy here on top of this so that we can see how it will be implemented down here. So let's run and see how it's done. Let's see, it will build. Fantastic. So you see, we have a hoof hoof. So what happens? We have the rule, and then each toy must follow the rule, but it's in all implementation, which means we can have something another thing. Let's say a cat. Okay, so a class of cat will be something like a public class of cat. A cat interfaces our iToy. iToy. Let me just type so that it can stick easily. And then the implementation of that rule by the class of cat. So it will be public void make sound. Then how does a cat implement this rule? That is what we define inside here. Console write meow meow. Then we come down in our main program class, in our main method, and then now we are going to instantiate that. How do we do that? It's a cat, the name of cat, which a new object of the cat class. Then we have an action or the rule that is implemented differently. So we have something like a cat, and then this cat makes sound, and that's it. So when we run our program again, we should expect a woof woof and a meow meow. So let me clear the terminal once more, and then we can run our C# program to see what happens. Let's see. Okay. So here's the thing. You see now we have a hoof down here, and then we have a meow meow for a cat. So you see what happens here is like we actually are trying to implement called reusability, where we have the rule is defined in the interface, and then some classes can now interface with it to implement that rule, but in their own specific implementation. Example, we have a toy. A toy can make a sound, right? But we have types of toys like a dog. A dog has a sound of hoof hoof, and then you have a cat has a sound of meow meow. But in common, they all make sound. And then you have to just call that in our main program to see how it works by just saying public class program, and then the main method, which is public static void main, then call the dog object. Then now you can call the method of the dog class, that is dog.make sound. A cat class, the cat object, then a cat makes sound. So that is like a basic example of our interface. So what happens, we made a rule for iToy that says like every toy must have a make sound method. Then both the cat and the dog follow the rule but make different sounds. Now, when we play with them, for example, having a dog that make sound, we get one sound for the dog. When we make another sound for the cat, we get a meow meow. So, like to summarize in a nutshell, what interfaces and generics actually do, like think of generics as the flexible boxes that can hold any type of a thing, and interfaces are like rules that different things need to follow, even though they can follow the rules in their own unique way. Yeah. So from what we have as example here, can we have any question or someone has something to add on top of what we've learned? Either Lex, an attendee, or Brian, our co-host, can have anything to add on top of that. Are we together?
Yes, we are together.
Yeah. Let's if there's no question, maybe I can hand it over to Kimboy to maybe if you have something to add on top of what you have just presented, or any more explanations, and then we can just call it a day.
Yeah, that has been an amazing presentation by Omollo Oganda. So we can give some appreciation. So just go there and react. Whenever you're reacting, you can send the applauding hand.
Yeah.
Right, that has been an amazing presentation by Omollo Oganda, and we've learned something new, maybe to almost anyone who is starting with these languages that requires object-oriented. I know if you've been doing JavaScript, you might not find generics and interfaces, but if you're doing something that's like TypeScript, or if you've ever done some C#, that's when you will find the generics and interfaces. So they might be confusing at times because we might have a question, or somebody might ask you a question like, what are the differences between generics and interfaces? So we've seen that that's an interface just defines a contract, or it defines the rules. You could see like whatever a doc will do, like its rule is placed somewhere. So that can be used whenever you want just to give certain rules that should happen, and then you can go on to implement those rules. Well, you want now like having them in methods. But if you could see about generics, it was just a placeholder that you could be able to define some types for other things. Like for instance, I want to just have a list that can take any type of anything. So I can just define a generic certain type. I can say a T type. It's always denoted by that T. So it could just take any type. For instance, I could just have a list of integers, a list of strings, and that's a better way to work, especially if you're working on a large application and you don't want to reuse yourself, you reuse your code. Like you want to repeat yourself, so you just reuse that generic, and it is typeset because you had Uganda talking about it's another way of how you could be able to have type safety in your code, and that's cool. Yeah, there are so many differences between it. I just did a table, so I'm just going to snip it from my side. It's a table that I have that will help you know the differences between just snip it over here and then send it to the chat. So this will help you like identify those two differences, because I don't want to like repeat myself talking about it. So you will always see the features of it send in the chat. So I also send in the WhatsApp group. Let me just start with the chat. And it's also good for you to practice this. Just it's a task. Just go to your Visual Studio Code, have everything installed or set up, then just create a project. So if these things get challenging to you, something to note is that you can, as well as involve us in that group discussion, because we have a WhatsApp group. We can be able always to talk about that. And yeah, and any other challenge you face, we have YouTube videos, we have the documentation all over. So if you are able to like use generics and interfaces at the same time, then you'll be good. Yeah. So I think this is a good table to show the differences between them. Could say about implementation over here, it's saying interfaces do not contain any implementation. So classes must implement them. So that's what Omollo was doing. He was first creating an interface over there, and then a class of a dog was now implementing those the setup rules. But generics will always provide the logic. Yeah, these things are easy to understand, especially when you are following up with the video or the demo from that. So it's here. Interface iToy. It just made that this a rule makes sound. And then a dog, that's a class. You could see that it was implementing that, okay, a dog could, this is the sound produced by a dog. So also a cat implements. So next week, Dennis Kaduri is taking us through object-oriented programming. And whenever you see these two semicolons, it means that you are implementing something. So this cat implements the iToy. So interfaces, before you write it, you must start the I. It's a rule in C# that you must always obey, because somebody might just come and say public interface toy, forgetting the I. So it's a convention, and it's good to observe the convention. So it's the two first letters should be capital, and then all that. And it's easy for you to implement if you get to understand it. So if anything, if anybody faces a challenge with it, So please be able to reach out. Omollo, you can also share the code. Maybe if you have it on GitHub, you could be able to share it. That the rest
yeah,
are
I
also
can share
practical.
GitHub. Then I'll share the link on group so everyone can get access.
Yeah. So
yeah,
I think that was it for today. Let's receive questions. If anybody has a question, this is the time to ask, because you could see now the topics of C# are now getting advanced and advanced. I think after we'll talk about object-oriented programming, we'll just remain with the almost few things of exceptions, and then we now start coding something on .NET, like ASP.NET. So that you can be able now to come up with a project. Somebody might be asking like, okay, what do I do after I've known all these fundamentals? So after these fundamentals, we shall get into now develop some real APIs and connecting to different databases. So, and now Omollo, is you are a fan of connecting a different application to databases like MongoDB will connect to.
yeah,
So it will be fun you connecting these to different databases. So we still have a lot of content, and we hope to see you next time when you join the call.
Sure.
So if there's still another question, this is the time. So we can prepare in advance for object-oriented programming. I think this requires you to always prepare ahead. Like for instance, now, maybe by next week, you can be able to know the 4 concepts of object-oriented polymorphism, what is inheritance. It helps you to guide, it will guide you while you continue gaining more skills. Yeah, thank you so much. There are no other questions. I think we stop there. That's been an amazing session. Thank you, Omollo, for your guidance today.
Yeah, thank you everyone for attending. You made it possible for us to have this session today. Without you, we couldn't have this session. So thank you guys. See you in the next meetup that is on Wednesday next week, when we'll have our host Dennis Katuri taking us through. So have a good night and do some C# coding. Yeah, bye. You can leave at your own pleasure.
Bye-bye.
Bye-bye.
Okay, Omollo, you can stop the recording.
I'm trying to check the stop, or I just leave it. It will leave. I'm looking for the stop. I can't see it here. Stop there. Let me see. Stop recording. Okay.